Mr. T with another trigonometry lesson. This time we're going to be talking about the trig function of any angle, or trig functions on the coordinate plane. So won't just be dealing with the right triangle, so our SOHCAHTOA definition for the trig is not going to serve us here. So we want to be able to take any angle. Remember, we start at our positive x-axis and we rotate some number of degrees, theta, and we want to be able to find the sine, cosine, tangent, cosecant, secant, etc. of that angle, no matter where that angle is on the unit circle. So I have a unit circle here. It's been divided up into degrees to show various angles, and it's showing the standard or the special angles that we use in trig, as well as continuations of those angles. So let's talk about how we could use the right triangle to come up with some formulas here. So let's just work first with this 30-degree angle. So the 30 degrees is here. This ray is formed by a rotation of 30 degrees. And we could sketch in a triangle here, because what we're interested in is this point that is swept out on the circle at xy for 30 degrees. We might be interested in both finding the coordinates of those points as well as how those points relate to our trig. Now we could drop a perpendicular here, and we've now formed a triangle, and in particular it's a 30, 60, 90 triangle. This dimension from here to here is our x-coordinate of this point, and this side is our vertical distance to that point, the y-coordinate. So if we looked at x, we could find the value of x. Now remember, this is a unit circle, so this radius here is 1. And in fact, we'll continue with this. So we could find the value of x by using the hypotenuse and the adjacent side. So the cosine of 30 degrees equals x over 1. So x is the cosine of this angle. So this x point, our value is cosine of 30. And we know from our special right triangles that that has the value of radical 3 over 2. Our y value is opposite, so we know the sine of 30 degrees is y over our hypotenuse. So this is the sine of 30 degrees, and we know that that has a value of 1/2. We now know these x and y coordinates, and we could find the tangent of this angle by taking the y over x, opposite over hypotenuse, and then we could simplify this, and if we simplify and take 1/2 over this and rationalize, we get square root of 3 over 3. Same numbers we had in our triangle. But as we extend this, if we pick any point on the unit circle, we can show that the xy coordinates on this unit circle, that at this point the x value will be the cosine of theta, and this value will be the sine of theta. From that we can develop formulas for all of our trig functions. Now most of the time we are not going to be on a unit circle, so let's clean this up a little bit and do one more thing before we write out the formulas here. Let's assume that this radius is r units, and again we can make our triangle here. Again, this is the x coordinate of this, and this is y. And this, again, for our first example, this is 30 degrees. But the sine of 30 degrees is y over r now. So if we solve that for r, well, actually we don't want to solve that for r, so the sine of an angle, a rotational angle, is y divided by r. So if we generalize that, it's going to be sine of theta is y over r. If we look at, to get x, it would be the cosine of 30 degrees is x over r. And the tangent is still going to be, because it doesn't use the radius, so it's not affected by the radius, would be y over x, opposite over hypotenuse. So let's clean this up and write some formulas down. So again, we have a unit circle here, and for now we won't be worrying so much about the specific numbers, but we do have a radius of r, and we have some arbitrary angle. We won't make it one of the special ones, which is theta, and we can write the x and y coordinates in terms of that. So if we know the x and the y points on that, if we know the coordinates on the unit or on the circle that are swept out by this angle of arc, we can write these formulas that we just figured out. Cosine of theta is related to the x coordinate, x over r. The sine of theta is going to be y over the radius. Tangent of theta is y over x. And now if we look at those reciprocal, remember the reciprocal of the cosine is the secant, and that's going to be r over theta. The cosecant is the reciprocal of the sine, so it's r over y, and cotangent of theta equals the reciprocal of the cotangent, x over y. So we're going to be using these formulas when we deal with trig of any angles or trig in the coordinate plane. Let's fill these out. Let me bring up a slide here where we bring up a unit circle that has all the values filled in. So let's make that bigger. So we can derive all these numbers by forming all these different special triangles, and we can get the x and the y coordinates on a unit circle. Now in this case these numbers are on a unit circle, so for this problem, for those numbers, we are back to talking about a unit circle, so we have radius 1 here. And we've shown here the angles in the standard angles in the first quadrant, and then this is another 30 degrees, 45 degrees, etc., 60 degrees. And we have the angles in radians all the way around the circle, and we have our x and the y coordinates. Now notice as we go into the other quadrants, the x values and or the y values are negative, which means our trig values will also be negative. When we worked in the right triangle, the trig values were always positive. So let's use this unit circle to say, let's figure out the sine of 4 pi over 3. So we have to remember on the unit circle, sine is the value of the y coordinate. Our y over r was our formula, but in this particular case our radius is 1. So just a 1 under here. So if we go to 4 pi over 3 and find its y coordinate, we know that the sine of 4 pi over 3 is negative radical 3 over 2. To find a tangent value, let's say we wanted to find the tangent of 11 pi over 6. Remember the definition of tangent is y over x. So if we go to 11 pi over 6, our y value is negative 1/2, and our x value is square root of 3 over 2. We turn that into multiplying by the reciprocal. Our 2's cancel out, so we get negative 1 over radical 3. And we have to multiply that by radical 3 over radical 3 to rationalize, and so we get our answer here is negative square root of 3 over 3. So we can come up with the sine, cosine, tangent, secant, cosecant of any of these special angles on the unit circle by knowing and or memorizing these x and y coordinates. And at the beginning I showed how these values relate to our special triangles that you've memorized back in geometry. And again, we can do these in both degrees and radians. So to wrap up here, let me give you a way of memorizing these special values, and we're just going to talk about the first quadrant. So if we have theta, and we can do it in degrees and in radians. So we go at 0 degrees, 30 degrees. I won't put the degree symbol in all these because we got the degrees up here, 60 and 90. Now we didn't talk about these angles here, 0 and 90. We may go back and do that before I do this. So radians, this is 0, this is pi over 6, this is pi over 4, pi over 3, and pi over 2. And for each of these angles we are going to figure out the sine, the cosine, and the tangent. Again, let's go back and talk about 0 and 90 for a second. These angles here, let me clean this up down here. These angles are referred to as quadrantal angles. They end up on the axes. So when we have triangles, we're not going to have those angles. But if we looked at pi over 2, let's look at the sine of pi over 2. Remember, is the y coordinate, so that's 1. And the cosine of pi over 2 is the x coordinate, 0. And let's look at the tangent of pi over 2. It's y over x, so that's 1 over 0. That's undefined. So some of our trig values are going to end up having undefined values. Sine and cosine are defined. They have defined values in x and y all around the circle, so they are defined everywhere. Let's just do one more. Let's look at maybe pi. So if we look at pi, the sine of pi is the y coordinate, so it's 0. Cosine of pi is the x coordinate, is -1. And the tangent of pi is y over x, which 0 on top gives us 0 as long as this is not 0. So again, we're finding the quadrantal values. You can do those for the other ones. So now let's go back to my pattern for how to remember these. If we look at the unit circle, our numbers for sine are the y. I'm going to put that in the first column. 0, 1/2, square root of 2 over 2, square root of 3 over 2, square root, or I'm sorry, a 1. Now the way I remember that is we put these as square root of 0 over 2, square root of 1 over 2, square root of 3 over 2. I'm sorry, I missed one. I skipped 2 here. Square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2. Notice the numerators go square root of 0, 1, 2, 3, 4, and the denominators are over 2. Square root of 0 is 0. 0 divided by 2 is 0. This is 1/2. Square root of 2 over 2 is in simplified radical form. This is simplified radical form. Square root of 4 is 2. 2 over 2 is 1. The cosines go in the reverse order. So we go square root of 0 over 2, square root of 1 over 2, square root of 3 over, 2. I keep making that same mistake. I don't like 2, I guess, today. And square root of 4 over 2. And if we simplify those, we get here 1. So radical 3 over 2. Square root of 2 over 2, and 1/2 and 0. And remember our tangent, remember this really on the unit circle is y and this is x. So we can take these numbers and calculate tangent. 0 over 1 is 0. 1/2 over square root of 3 over 2. If we simplify that and rationalize, you'll get that. Here we have radical 2 over 2 over itself. Something divided by itself is 1. Here we have radical 3 over 2 divided by 1/2, which simplifies to be radical 3. And here we have 1 divided by 0, which is undefined. So I just wanted to show you, but if you can remember this pattern and that this is reversed, you can figure out sine and cosine for these special angles and find the tangent. Once you know these for the first quadrant, we can use a unit circle and go horizontal and match up x and y values, and we know in the quadrants whether x is positive or negative, so we can figure out all the values. So this is the introduction to trig on the coordinate plane.